Okay, so now the orbital diagrams, it's the same thing we were looking at, but here's how they fill them in. If you'll look at the periodic table while we do this, you'll see the periodic table will come alive to you. 1s1, 1s2. What's going to be next? What's going to come next? 2s1. So the third electron has to go here. And that must be lithium, isn't it? Is that 3 electrons? Now, where is the fourth electron that beryllium has? It's 2s2. Is this coming together? 2s1, 2s2. Look on the periodic table. Isn't beryllium at a 2s2 place? Now, we got to go way over to the p orbitals. And here we need to watch now. This guy named Hund, and that's not in your book. That's why I have people writing a book. Hund's rule. This guy got famous. I didn't get famous. He said in the p, d, and f orbitals, here's the way you have to fill them in. You have to put 1 in each p orbital. So what element is that? Boron? What's this guy? What's this? 1, 2, 3, 4, 5, 6. Who's element 6? Carbon. Who's this guy? Nitrogen. Yes. Then you can go back and pair them up. Who's that? Oxygen. Fluorine. And oh wait, neon. You know what's special about neon? Any, except for helium. Except for helium. If you have 2 in the S and 6 in the P, that means you have 8 valence electrons. And if you have 8 valence electrons, except for helium, you're a noble gas and you stop reacting. Anytime you have 2 in the S and 6 in the P, you are a noble gas. Now, let's go to the next element. Who do you think the next element is after neon? And does he have 11? Where does the 11th electron go? Can't put it here. I'm putting it right there. And look at the periodic table. Isn't sodium located where 3s1 is? I gotta look at your faces because either all of a sudden maybe something's coming alive to you. You said, I get this now. And where's the next? Is this magnesium? Where's magnesium's last electron? Look, is it in 3s2 on the periodic table? Now we're going to go way over to the p block again. Who's this next guy? Aluminum. Now watch, look at my finger here. Look. Aluminum has a lot of electrons, doesn't it? If I ask you how many valence electrons aluminum had, outermost energy level, it's not this level, it's not that level, 3. And what is the Roman numeral right above aluminum? 3. The Roman numeral above that tells you how many valence electrons I have. Everybody here has 1 valence electron? 2, 3, 4, 5, 6, 7, 8, except for helium. Yes? If you put this picture together, you'll say, this is easy. This is pretty easy. All right, what's the next element? That's aluminum, right? What's the next element? What's the next element? The next one? Now, then you go back. Now you can compare it. Now you compare it. Now you compare it. Uh-oh. 2 in the S, 6 in the P. I'll bet I'm at a noble gas. What is it? If this was neon, what's this? Is this argon? Right. Everybody get it? Now, here we go. This is as far as I take the non-honors chemistry. I'll go one more step with you. The next electron should go into 3D. But look at the periodic table. The 19th electron does not go there. Where does it go? Look at the periodic table. Where does the 19th electron go? The periodic table says it goes into 4s1. Now, if you want a fancy explanation, chemists said it was easier to go to the 4th energy level and have a s orbital than one of those complicated d orbitals. Where's the 20th electron? The 20th electron, is that calcium? And now something weird happens. Scandium, the first element in the D block. Where do you think is going to happen here? What do you think? 1, 2, 3, 4, 5. Come back and pair it up. 6, 7, 8, 9, 10. Do you know? Wait a minute. Wait. Can you tell me what element we're at right there? It's the last element in the D block in the 3D. And so what you watch here, this is called 4S, and this is called 4P. But when you get to the D block, you have to subtract a number. What? 4S1, 4S2, 3D1, 2, 3, 4, 5, 6, 7, 9, 10. Now go back to 4P. The S and P will never fool you. The D block, you subtract one number, and it goes in and fill it. It's a beautiful system, and that's why the periodic table is written the way it is. That's why it has the shape it has.